Okay, good evening. Uh, Today's session, we will discuss the network reference model. After I think the last session where we did the introduction, which was more of an introduction to basically what networking is. With this one, we discuss how data is originated and how it is transmitted. And to best explain how data is originated, where it originates from, and how it is transmitted, we have my reference models that we use. To be more specific, we have two that are commonly used, the OSI and the TCP/IP model. So basically, what we're going to be doing is explaining the data. When we talk of networking, is we establish a network so that we exchange information. So starting point of exchanging information or any resources is originating that data, message, the information you want to send. It has origins. And how does it originate? It is usually from our computers. Then from there, it will need to be transmitted, but the process itself, understanding the process itself from data origination to transmission, then on the other end, you receive the data. It needs to be understood because taking care of the network, knowing how to take care of the network, needs you understanding the whole process from origination to transmission in Ngekamira, say basically. So with this, that is basically the aim of the chapter. My main objective is to understand the data definition and transmission processes, understand the concepts, advantages of the network reference model, understand common standard protocols, understand encapsulation and de-encapsulation processes. Starting with origination of data. So we have my applications that we use. For example, here I can say I'm using Zoom. That's the application that I'm using. So it's the application that allows a presentation here data and Ruguda so that I can send my voice, I can send that is on my screen, so that imim on the other end, on the receiving end, mkwanise uzviona. So basically, data originates from our computers, and we have my applications that are responsible for that. And always learn kupinda permitting or mute. That's very important. I always assume people know that. Right. So data generation in the computer field, data is the carrier of all kinds of information. Data transmission, data generated by most applications need to be transmitted between the devices. I think this is more of a repetition of basically what we've been saying. Uh, as I'm communicating with you, it means I'm sharing information. How is the information being originated? We have an application, Zoom, and then I speak on my microphone. There is information on the screen. Zoom take care of that information, then converts it into a way that it can be transmitted. After transmission, it gets sold to you on the other end. Then it is decoded back so that you can see it on the screen. That is what the process, that is what the reference models basically describe. It makes it easy to describe that whole process. It sounds simple, just saying to a Zoom application, process whatever information and rule sender, then you have to transmit where on the other end you receive that information. It's not as simple. So I think mostly we'll be focusing on, okay, am I right? What happens in between here? Up. What happens in between here? That's the network. What is basically happening there is best explained near to the reference model. Right, getting into reference model, OSI. So the OSI is mainly seven layers, uh, where you have to understand what each layer does. Basic. What does each layer do? Then you have to understand particularly I'm sending information, making use of application in Zoom and obviously the network. Yoitwa transmitted up until yasvika kwauri. Or at each of these layers, and through the process here, data transmission is origination and data transmission. Where exactly are you and what is happening in each of those layers? That is very important. So you have to understand country application layer, what's happening there. With respect to an example and up transmission, you have to be the easiest currently. So at the application layer, that is basically uh, the layer that provides interfaces for our applications. That is where users interact with the network. So I mean, I'm a user, I'm interacting with my network via the application name with Zoom. I also have PowerPoint, which is running. Then from there, the application layer, that is where the data origination comes from, I think. Then we go to the presentation layer, where it translates data formats to ensure application layer data of one system can be identified by application layer data of another system. So that's more of encoding at at a level, yeah, at a higher level. We have different types of encoding. In when we go presentation, we have other types of encodings. It goes as the physical layer. So here we are more concerned with type of encoding. You get, for example, compression, encryption, and maybe these two. This is more of the data encoding that is done in the presentation layer. So we change my formats. We change my formats from what information is presented to the application layer and what is understood as we go down my layers. That is the encoding that happens in the presentation layer. Then we have the session layer, which establishes sessions. I always say the session layer is more of when you're having a conversation, ngotanga kuita nyaya, their introductions probably munomhoresana, then kana mapedza nyaya munobhabhaisana, meaning mapedza nyaya. So the session layer is responsible for that. Every time you have a device is communicating, then there is need for my hellos kumhoresana kuti, so that you know that you are now going to be sending some information. Then kana mapedza communication, you need to highlight kuti izvezvi zvitapedza communication so that we can close the dialogue. So the session layer is mainly responsible for that, establishing, managing, and terminating my sessions, so that we don't have security problems. Because if you leave my dialogues open, that's how attackers get access to some of my information, because the dialogues are still open. So someone can manipulate network element attack. Transport layer, this one is more responsible for reliable delivery of information. As we move information from a point A, B, there is need the reliability of the information ichasvika. And the transport layer is more or less involved with that. So it establishes, maintains, cancels end-to-end transmission processes, controls transmission speeds, and adjusts data sequences. From that statement, you can see it has a lot that it does, the transport layer. But I usually advise you to tanga nekunzwisisa the basics. Tisati tatanga kuwandirwa nezvakawanda zvatisinganzwisisi. For now, the transport layer, think of it as that layer which is responsible for reliable transmission. So it makes sure information yedu yasvika kwainofanira kusvika. Kana isina kusvika, it at times, depending on protocols ari kushanda, it tells us kuti information hainosvika, so that we know. Kana information isina kusvika, it then allows us to resend. If we don't have that layer, we're not going to send the information, but we don't have any way of knowing kuti yasvika here kana kuti hainosvika, kind of a thing. So the transport layer, it has a number of protocols which are responsible for that. Then the network layer, that is where IP addressing starts there. I think in summary, the network layer is responsible for routing. I'm sure you have heard of routing and switching, routing or switching. This is where routing happens, finding the best path in a network, knowing kuti traffic yangu kuti isvike ku point B. How does it have to go? So you realize that network, it is made up of a number of nodes, akawanda, billions of nodes, millions of nodes. Not sure about my numbers. A said they're interconnected. Then this is point A, this is point B. Panopinam network, you have all these interconnected nodes. It can be your switches, it can be your routers, firewalls. The network layer is responsible for knowing kuti ndisvike kuna B. If I'm moving from A to B, kuti ndisvike kuna B, what is the best way to get to B? Because we have a number of ways to get there, but what is the best way to get there? What is the best route to get there? So it makes use of my IP addresses, trying to find ways to get to a point B. Same way ngachienda, I'm sure ngachienda ku Bedbridge, Bodo, we can use Masingo Road. I'm sure you can take Blawa Road, no gonna shika. I'm sure can Mtare Road, no gonna shika. But we all know probably Masingo Road is the best way to go. That is what that layer is involved with, the network layer, choosing the best path to get to your destination. Then the data link layer is responsible for what we call data framing, physical addressing, MAC addressing. In short, it encapsulates packets into frames. I think Shirungu is a bit complex, but it's basically that layer which is responsible for physical addressing. The layer number 3, network layer, in a non-logical addressing. I think the difference between them is more can I send the information from Harare to Blawayo? Let's start with what we call local communication. If I'm sending information within Harare, I use my local addresses. So I can use, I'm sending information, Budiriro, I'm sending information, Koavondeo, kind of a thing. Those are sort of local addresses that I'm using because I'm in Harare. But if I'm trying to send information, let's say from Blawayo to Harare, we call that remote communication. It's not local, it's remote communication, kind of a thing. It's an example, analog. So if I'm sending from Blair to Harare, the first thing that I say is I'm sending information to Harare. I don't say I'm sending information to Budiriro. I can specify the local address, but it's mostly I'm sending information to Harare. Then I'm sending information to Harare in Budiriro. So that's the difference between my addresses are. So the network layer addresses, they are more remote. If you have remote networks, then these ones are more local. If you have a local network, you can use my data link layer MAC addresses. So the data link layer is responsible for framing. Framing is basically adding my MAC addresses to the information needed to send. Then lastly, we have the physical layer. The physical layer is responsible for transmission. So ndopane transmission yedu, and as my telecommunication students and networking, I think let's say telecommunications. Telecommunications is mostly it mostly evolves around this layer, but transmission. I think ndopane telecommunications, the type of different types of media that we have, wired, wireless, fiber, copper, wireless, microwave, satellites, whatever mode of uh, transmission that we are using, that is where it is mostly involved. That's the physical layer. So if you take a look at it, these reference models, it makes it easier for us to understand good information from origination through transmission could get to the other end, what is happening. This is how it happens. In this example, yevideo redu repazoom here. Information yangu is originating in this upper layer from my computer, application yangu Zoom. Then it is then converted in the presentation layer. Ndikushanda voice rolo richada kuiswa to a digital signal. because voice rangu, that's not a digital signal. So it will need to be converted to a digital signal. That's probably part of the presentation layer. Then there is some compression sciatica so that we can transmit information here in a smaller sizes, even faster to transmit. Probably there's some encryption in it so that we don't allow people to tap in vasingafana kunzwa information. Then from there, hello, makasimba here, that's my information communicating with all your devices. Patanga session, at the beginning of the session, there was the establishment of that dialogue. Then this one will be responsible for logical connections between our two devices so that we have reliable delivery. Kana pane munhu asina network izvezvizvi asiri kukwanisa kureceiva message iyi, probably our two devices are communicating. Could that other device is not getting that message, continue trying to make a connection so that you can get back kana network yadzoka, kind of a thing. That's what the transport layer is doing. Then the network layer, information yese yandiri kuda kusenda, it is being attached an IP address so that izive kuti iri kuenda to the destination up until it gets to your devices. Then the data link layer, the local addressing, then the physical layer, information yangu pa PC yangu yakuenda wirelessly via Ethernet masiwa yobva yasvika on your PCs. Then yasvika on your PCs inosvikira pa layer rinori. Kana tichisenda toita process inonzi encapsulation tichidzika kudai so encapsulation, then kana takureceiver takuita process yakadai de-encapsulation. So network yamasiwa yasvika kwamuri, whichever other network you're using, zvinosvika paphysical layer zvokwira up until you get to the physical to the application layer. Application layer ndiyo yakudisplay zvauri kuona pascreen, and that allows us to basically communicate. And that is how the reference model helps us in explaining how communication works via making use of my networks. Right, then we have the TCP/IP reference model. If you understand the OSI, it becomes very easy to understand the TCP. Akadao tufanane. So you realize with the TCP in formal layers, where are they? Transport network, these ones. So this is the TCP in an application, in a transport, in the internet, then in a network access. Right? Then you just realize that the application layer TCP inenge yakabatanidza three layers OSI, the application presentation session. Transport remains transport as it is. Then network becomes internet. Then these last two, the data link and the physical layer, another button is all from the network access, but the function remains the same. The reason why we are making the TCP IP, I think it's more practical. It allows us to, for example, understand how my protocols work together. It makes it much easier to do that. The OSI, in theory, it makes sense, but can tap a ground trying to understand how that network works, it's much easier using the TCP IP. But zvakangoda kufanana zvese. So if you understand the OSI, you can definitely understand the TCP IP, because my layers acho akada kufanana, my protocols acho definitely akafanana as well. Then common TCP IP protocols, we have a number of protocols that we use. Defining what protocols are, I think is very important. A protocol, it's a rule. A protocol is a rule. If we are communicating, for example, what we are doing now, there are rules that are set kana tichicommunicate. Ndati hapana munhu ari kutaura kana tichirecorda. You can ask questions after munhu wese akanyarara. Those are rules that I've set so that we can be able to communicate zviri proper. I'm speaking a language probably everyone understands. And let's speak a language that everyone understands. That's a rule as well. If you're communicating, probably you need to be communicating with a language everyone understands. So those are rules of communication for us humans. Computers, they also have rules when they are communicating. Marules iwayo are what we call my protocols. So from my layers at Ataura essay, there are protocols within every layer. There are rules within every layer, which allows my computers to exchange information. So for example, the simplest rule is probably DNS. The simplest rule for me to explain is probably DNS. So that's a rule which says if two devices, if you want to access the internet, for example, if you go to your web browser, would end up on YouTube. So you're interacting with the application layer, and also end up on YouTube. Unaenda on youtube.com. YouTube.com, this is what we call a domain name, right? Then what you are doing is basically trying to connect to a server at a YouTube. Server error is identified by an IP address. So wherever if you type in www.youtube.com, what you are doing is you are trying to make a connection to IP address a server is. But you don't type in the IP address directly. You can if you know it, and you still be able to go by YouTube. But most of us don't know about my IP addresses. In me, I expect you to know that, but most people, obviously in the networking, telecommunication, they don't know about an IP address. So what they know is YouTube. Honestly, I don't know about YouTube, but they don't know behind that there's an IP address, a location, kune YouTube server racho kwakudotora information. So DNS is the type of protocol which says munhu akataipa youtube.com, then it allows that person kuenda to that respective IP address. That's how the protocol works. So it's a rule which says ukaisa domain name, if server rako DNS server knows the IP address, then it gives you the IP address and it allows you to connect to that. If it doesn't know, you probably won't be able to make a connection. Inotokuudza kuti DNS server not available, etc., etc. So that's how protocols work. Protocols is the exchange of messages between my devices, allowing us to have communication. Where you are required to know, I think my protocol is SR screener. That's basic. You're allowed to know. You you are supposed to know what does each protocol do. Telnet, you learn about remote access, FTP, you learn about file transfer, TFTP, that's another form of file transfer, SNMP, monitoring, HTTP, something to do with websites, representation of information in our website, SMTP, emails. I'll send my emails, you're definitely making use of STP, DHCP, IP addressing, TCP, UDP, transport layer protocols, reliable communication for TCP, the other one, not so reliable, connectionless as well. The other one, connection oriented. Those are the kind of things you need to know. Because each of these protocols, what are they responsible for? And in which layer do they belong to? Kana tazodhipisa, you understand the type of exchanges that are being made. I think another one which is easy to explain is DHCP, the type of exchange of messages ziripo. That a protocol is a rule. A protocol is an exchange of messages. So if I have, let's say, a server rank in the form of a router and I have a PC yangu, that's a PC network. PC yangu kana ichipinda network is either assign an address physically, manually, or it gets assigned an address automatically by via protocol at DHCP. So how the protocol works, PC ikapinda network send a message to server, which is our router. I don't have an IP address. Router will respond, I'm offering you an IP address. This one you respond, I'm taking that IP address. Then this one, okay, you now have an IP address. That's an exchange of messages. That is what defines my protocols. So, pese partial communicator, there is exchange of messages between our devices behind the scenes. We don't see it. It's our screens, but behind the scenes, behind everything, there is communication between our devices, between other intermediary devices, and that is what defines anonymous protocols. Right, then we have my organizations, my protocols actual rules. Rules are made. Who makes the rules? I'm not so sure about edu angandutaura communication is something probably consciously know kuti kana chitaura nemunhu anonzwa shona ndotaura neshona so that anzwe oro takuswitcha kuenda kuenglish probably someone who understands english because it's a universal language oro takushedza translator kuti akwanise kutranslate whatever weare trying to communicate. Probably someone set those rules way before us. It's the same thing. Co-communication, there are people who set those standards. Those ones, we know them. We have my organizations. I think you are very familiar with IEEE. Wi-Fi, for example, that's a standard, the IEEE. IEEE 802.11, Ethernet 802.3. You have to be familiar with these standards because communication in USA is those organizations which are responsible for setting the standards. You kada kuita ma-standards ako wega probably unovharwa panze because of those organizations. You have to adhere to the rules which are set by those organizations. So those are some of the common organizations which are responsible for the standards that we use. Right. Ending in 10 minutes. Right. Now, from here, I think we are more now getting into every layer. Could every layer ringe riri kuita nezvei exactly? I think we've probably not exhausted, but briefly explained with application and interaction with the user interface. How are we interacting? If you're interacting with a web browser, you're probably interacting with HTTP. If you are interacting with a system which is used for remote access, accessing my devices remotely, you're probably using Telnet. If you are transferring files, you're using FTP. If you're sending an email, you're using SMTP. The TFTP, that's another file transfer protocol. Those are the basic protocols that you need to know. Application layer. Common application layer protocols, FTP, file transfer. I think theory wise, I'll leave this to you so that more not how does it basically work. I think FTP is a protocol at Shabata Kumberi. It probably has a whole chapter repo. Telnet, remote access, HTTP. Every time you access a website, you're using HTTP basically. So I'll leave that to you. Could you pin it a little bit deep in that theory? The transport layer, reliable delivery of information, making use of TCP, which is a connection-oriented reliable protocol. We also have UDP, connectionless. Difference, connection-oriented is more, it has a huge payload overhead. It has a huge overhead, which allows communication needed to be reliable. So with communication reliable, there needs to be things like acknowledgements, acknowledging kuti information yasvika here kana kuti hainosvika. Kana isina kusvika toita resend. Kana yasvika we acknowledge kuti yasvika. Those extra messages dzekuti yasvika here kana kuti hainosvika, it leads to a lot of overhead. A lot of overhead means information yedu inenge yakakura. Kana yakakura, it needs more time to be sent when you are transmitting. It means it needs more capacity. So when you talk of reliability, it's okay, yeah, but transmission aid is not as easy because we have a lot of overhead. When we're talking of UDP, less overhead, simple communication. Yekuti tinongosenda chero zvasvika chero zvisina kusvika, we are sending tichifunzira kuti zvinosvika. So it's a bit quick to send using that protocol, but it's not just as reliable. That's the difference between those two protocols. But in general, the transport layer is responsible for making sure information has to go on the other end, depending on the protocol which you will be using. As you can see from my header formats, you can see TCP actually is bigger. I mentioned issue to do with a lot of overhead. You can see in a 20 bytes, the other one in a 8 bytes. It's easier to transmit 20 bytes than it's easier to transmit 8 bytes, sorry, than 20 bytes. So for this one, easy transmission, longer. Let's not say easy, let's say quick, probably. It takes longer to transmit that one. However, this one is reliable, not as reliable. So when you're designing a system, when you're designing your network, you just need to consider the compromise between reliability and time you send them from a point to another. So when all numbers need reliability and you need to send information quick, probably UDP is the protocol that you need to use. TCP, it makes use of my port numbers. You learn about my port numbers as we go. They are usually defined by the destination port number. So if I'm trying to access a website, in I'm the client, then server, I'm trying to access a website. Website I don't try to access, I didn't get it stored by server. So if I'm accessing it using port 80, for example. So that's the port number. We have specific applications or protocols which use specific port numbers. My port numbers, they are sort of like my addresses. So kana ndoda kudya lunch ndonoenda to a restaurant handiendi kuhospital. So restaurant, that's the port number that I'm using. Kana ndoda kuaccess a website ndinoenda to this port number 80. I don't go to 90 because hakuna website go. So we have specific port numbers for specific applications. 80, that's one. Which other one do we know? 20 and 21. If I'm trying to access anything via FTP, I use 20 and 21. 22, it should be SSH, 23, Telnet, 25, SMTP, 67, DHCP, DNS should be 53. You need to be familiar with some of those port numbers for specific applications or specific protocols that we use. This is just introduction, by the way. I think some of these things as we go, starting out deep square a little bit, but this is just to give you an idea of what is happening. Right, that is an example of a TCP connection. It has what we call a three-way handshake, which is basically sort of a connection establishment. Three-way handshake. TCP tataura nyaya reliability. The way it allows reliable communication ndeyekuti it sets up a connection using the three-way handshake. So before any information is sent between devices A and B, pasapa send any information, this device sends yet not a synchronization message, a sync. That's the first message we sent. So synchronize is more sending a message with in as device A, I want to communicate with you, device B. Then device B sends an acknowledgement sending OK. Ndazvinzwa toda kucommunicata neni. Then this one, sync acknowledgement. Then lastly, so this is a sync message, Russian walk. Then this one acknowledges, good OK. And ndanzwa toda kucommunicata neni. This one also acknowledges, good OK, I've received your response, toda kucommunicata neni. Then this three-way handshake means these two devices know that they are ready for communication. Now, if you know you're ready for communication and then nothing happens, that's a problem. So, for example, three-way handshake yaitwa, but no actual information comes from A to B. Then B knows something is wrong because someone auya akataura kuti anoda kucommunicata neni, but they're not communicating. That's how messages are sent back. Kuti communication how far kwamunozosenda zvangamunoda kusenda, kind of a thing. That's how networks work if they're using TCP. And that's how TCP is a reliable protocol because it allows for exchange my messages while ekuti communication anoitika saka sei isina kuitika. So pane information iri kuera, okay, yamasenda yacho yasvika or haina kusvika. TCP, reliable communication. However, a lot of overhead. To my exchange more messages, it means a lot of overhead, means not so easy transmission. We need a lot of capacity to to transmit. So that's the three-way handshake. Basically, exchange, yes, synchronize acknowledgement, then an acknowledgement from sender. That exchange, then was three-way handshake. Then sequence numbers and acknowledgement numbers. How does it know? How do devices know good information has been sent or has been received? It makes use of my sequence numbers and my acknowledgements. Right. Maybe I can see my time is up and up. I think we are not halfway. Don't discard. Okay, discard. We are not halfway, but I think another session will definitely allow us to complete. So what I want you to do, use the same link, join in um topics session redo, then we can have questions after. Tinenge patango sira ipapo.